So welcome to Algebra 2, right? So this is where you watch a video and Milbrath does about half your homework. I usually do anything ACT related just because some of this stuff has been talked about, some of the stuff you haven't seen in forever. You are required to show a work. Matrix multiplication is something that's going to be new to your class, so here's a practice problem from preparing for the ACT, I think it was 2024. Given the matrices x equals -1, 0, and y equals -2, -1, which the following matrices is matrix X times matrix Y. So matrix multiplication is a little bit different. You have to get these things oriented the same way too. I'm going to take matrix X and I'm going to make it look like this. I'm going to turn it from being a single row and two columns to being two rows and one column. And I'm going to find what's called the dot product because that's what it is. I'm going to leave y the same. What we do is we multiply across. Probably spelled across wrong, and then add down. I'm nowhere near 100% today. But anyways, if we take -1, -2, and multiply them together, we get +2. 0 and -1 make 0, and then we add down 2. Singular matrix that contains the element 2. Regardless of how the graph is oriented in a standard XY coordinate plane, no graph in one of the following categories has a vertical line of symmetry. Now, what is a vertical line of symmetry? Not everybody knows this. I've done this for a long time. I'd say you ask 1 in maybe 8 kids what vertical is, and they'd hold their hand horizontal. But vertical line, it literally cuts something in half vertically. If I had a piece of paper, that'd be a vertical line. Now, the first thing up here is a line, and a line can be drawn like this, or a line can be drawn like that. You can cut that in half, all right? So, not a line. We have a square, kind of like a piece of paper, that's more of a rectangle, but a square can be cut in half vertically, that's right. If you took a regular pentagon, which is a 5-sided figure, which is kind of hard for me to draw, I'm already kind of drawing a hexagon here. If I could orient this piece of paper differently, I could have cut it there. Pretend that was oriented better. It's not a pentagon. A parallelogram can definitely be cut in half vertically because a parallelogram can be a square or rectangle. They can be. They are, by definition, parallelograms. Maybe remember that from geometry. The parallelogram family contains the rectangle, and rectangles contain squares and so forth. Scalene triangle is a triangle with, it's supposed to be a W, 3 non-same side lengths. So scalene triangle is, the ugly triangle. I can't cut those in half perfectly. It's the scalene triangle. Choice K. 41, the equation 24x squared plus 2x equals 15 has two solutions. Which is the greater of the two solutions? I don't know. I'm going to do something from Algebra 1. I'm going to factor maybe. We'll try it. So we got 24x squared plus 2x. We jump to 15 to the left, and that's an x squared. Factors is 24. Let's go with 6x and 4x. Because this will yield 24x squared when we multiply them together using the FOIL property. Factors 15, probably 5 and 3 might be the pair I want. Maybe I have 2 in the middle. Yeah. So -15 plus 5 minus 3. Now some of you guys haven't seen factoring in forever, but the product of those two things is -15. This will give me 20x, and this will give me -18x. Put them together, you get 2x. Now we're going to use something called the zero product property. 6x plus 5 equals 0, or 4x minus 3 equals 0. We'll subtract 5 from both sides. We'll divide by 6, and we get a solution of -5/6. The other one, we're going to add 3 to both sides. and we're going to divide by 4, and we're going to have 3/4. Now it says which one is the greater one? Well, obviously 3/4 is bigger than negative 5/6. We have 42. 42 is a trigonometry question. Some of you guys will take me for pre-calc, and some of you won't. So one of the identities we learned in pre-calc, and this is an identity in pre-calc, talks about the sine of alpha plus beta, and it's going to be sine, I guess it really matters here, but it's going to be sine alpha cosine beta plus cosine alpha sine beta. So alpha is going to be 60 degrees and beta is going to be 30 degrees. Now, I don't expect the average algebra 2 kid to memorize this. I don't. But it's going to be J. Here's what we hope that the average algebra 2 kid does on ACT day. We hope that you're smart enough to turn on a calculator. All right? By default, a TI-84 is going to be in degree modes or radian mode. So I'm going to go to mode and I'm going to highlight degree. And then I'm going to type in the original expression. The original expression is that the sine of 60 times the cosine of 30, and I'm typing in it exactly as it's written. If you don't have a TI-84 at home, that's going to be part of your problem this year. Plus the cosine of 60, and the librarian can give you one. Sine of 30. What is this? Well, what is the numerical value of this expression? It's 1. So I'm going to go through and type in some answer choices. Like choice F is cosine of 60 minus 30. Which ought to be root 3 over 2. There's the decimal of that. So it's not F. And you can just literally type in the expressions. Cosine 60 plus 90, that's going to be 0 before I even push the buttons. But I've memorized things. Oh, 60 plus 30. I typed in 60 plus 90. Like I said, I'm not 100%. Anyways, I told you it was choice J. Sine of 60 plus 30 is 1. Just like I got right there when I typed in the original expression. Everybody can be a button pusher. There's no excuse for it. 43, what is the area in square units of a circle that has a circumference 12 pi units long? So there's two formulas I need to know. I need to know that circumference, I guess it's going to write, is twice pi r. And I need to know the area for a circle anyways is pi r squared. So I can take the original circumference and I can put it right there where C is. And I can say 12 pi must be 2 pi r. And what I can do is I can divide both sides by that 2 pi to isolate the radius. Cancellation on the right. 12 over 2 is 6. Pi is cancel. 6 is my radius. And now I can just simply take that 6 and I can put it there. So the area is pi times a 6 that's squared. And if you're a little slow, do 6 times 6. It's going to be 36. Always has been, always will be. 36 pi is the answer I'm looking for. It's an easy problem. It's an 8th grade level problem. It really is. 4, a barrel contains 25 liters of a solvent mixture that is 40% solvent and 60% water. Lee will add pure solvent to the barrel without removing any of the mixture currently in the barrel, so the new mixture will contain 50% solvent and 50% water. How many liters of pure solvent should Lee add to create this new mixture? We can do this one without algebra. It might be a little easier. So here's what I'm going to do. I'm going to figure out the current amount of solvent. All right. So current amount of solvent is 40% of 25 liters. 0.4 times 25, which ought to be 10 liters. Now the goal is that this new mixture is 50% solvent, 50% water. So let's just do some simple math here. Like let's add 5. All right, let's go with this one, which I'm pretty sure is the answer. So I add 5 liters of solvent. I now have 30 total liters. Now, if I added 5 liters of solvent and I already had 10 liters, there is now 15 liters of solvent. And the goal was to get to 50-50, and I know that 15 is 50% of 30. Not everybody does, but there's the answer. I add 5 liters of pure solvent. You can just logically think your way through a lot of this stuff. And that's how I would do 44 if I was you. I wouldn't write an algebraic equation. I'd just plug in numbers until I get one that makes sense. 45 for all x, where x is not plus or minus y. So if y is 3, x cannot be plus or minus 3. So these are different, okay? They have to be different. X over x plus y over x minus y is what? Well, here's a very good strategy. It's called make up numbers. Make up numbers and don't use 0, 1, or 2. So I'm going to let x be 3. I'm going to let y equal 4. Well, let's just see what happens here. So I'm going to let x be 3. Everywhere I see an x, I'm a 3. Everywhere I see y, I'm a 4. So this becomes 3 over 3 plus 4 plus y is 4. 4 over 3 minus 4. And this becomes 3/7 minus, it's going to be minus, we'll say plus for now, 4 over -1. So 3/7 minus 4, which, you know, I know you guys are probably pretty bad with math. I hate it for you. It should be -25/28. That seems right. But let's check myself here. I had 3 over 7 minus a 4. Math, answer frac. I don't know why why did I say 28s? What's wrong with me? That should have been 7s. Something wrong in there. Anyways, that's what I get when I plug in a 3 and a 4. So what I'm going to do now is I'm going to check against the answer choices. So if I do this one, this would be 1 over 3 minus 4, which is going to be 1 over -1, which is -1. Obviously, right? If I go to the next one, I'd have 3 plus 4 over 3 minus 4. This is what, -7? Check C. 3 plus 4 over twice x, 2 times 3. That's 7/6. Choice D, 3 squared. Oops, got off. 3 squared plus 4 squared. That's not it. That's, what, 25? Means it's going to be E. So let's just check my work, make sure I'm doing things right. This is 3 squared plus 4 squared over 3 squared minus 4 squared. So the top's going to be 9/16, which is 25. The bottom's going to be 9 minus 16, which is -7. And those are the same thing. So it's choice E. 46. Mary, James, and Carlos sold 1/4 page advertisements for the school yearbook. Mary sold twice as many as Carlos did. James sold 3 times as many as Mary did. What fraction of these advertisements did Carlos sell? This is a strategy I use all the time. It's literally call the smallest thing x. And the smallest thing here is Carlos. So Carlos is x. Now, Mary sold twice as many as Carlos, so Mary is 2x, and James sold 3 times as Mary, and if we do 3 times 2, we get 6x. Now, if we were to add all these together, the total is going to be 9x, I think. What fraction of these advertisements did Carlos sell? Well, so Carlos sold x out of 9x, or because of cancellations, 1 in 9. 47, in a window display at a flower shop, there are 3 spots for 1 plant each. To fill these 3 spots, Emily has 6 plants to select from, each of a different type. Selecting from the 6 plants, Emily can make how many possible display arrangements with 1 plant in each spot? Note the positions of the unselected plants do not matter. This is going to be probably the fundamental counting rule, something along the lines of combinations or permutations, which we will discuss after Christmas. But I have 3 choices to make. And I start off with 6 plants, so I can make 6 choices here. But I've put a plant here, so now I can only put 5 different plants there. I can pick 1 of 5. I've made another choice, there's only 4 left. And we just multiply those things together. 30 times 4, there's 120 ways to make that decision. So yeah, that's the fundamental counting principle. And that's the homework I'm doing for your first night of homework. That leaves you with 6 problems due on your own. I think you'll be all right.